Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Meta's hyperscale infrastructure. It's a fascinating look at how they've built their planetary scale system. Let's get started.
I'm eager to hear this. Meta's scale is mind-boggling. What are some of the core principles driving their infrastructure design?
Absolutely. A huge part of it is their move-fast culture. Continuous deployment is king. They're pushing code to production constantly. This, coupled with a heavy reliance on serverless functions, really boosts developer productivity.
That's intense. How do they manage the risk associated with such rapid deployments? Doesn't that increase the chance of outages?
That's a great point. They mitigate risk through extensive testing, staged rollouts, and robust health checks. They've also invested heavily in automating deployments, bringing that number up to 97% fully automated. Impressive, right?
Extremely. And what about hardware costs? Managing that much infrastructure must be incredibly expensive.
You're right, it's a massive undertaking. But Meta cleverly uses hardware-software co-design at a data center scale. They treat their entire global network of data centers as one giant computer, dynamically allocating resources across the board. They're not just optimizing within a single data center. They're optimizing globally.
That's a novel approach. How do they achieve that level of global optimization?
It's a multi-layered approach. They have tools that manage capacity globally, regionally, and even at the individual server level. They use things like mixed integer programming to distribute workloads efficiently. It's incredibly sophisticated.
Wow. So they're essentially using software to overcome limitations of cheaper hardware?
Precisely. They've even optimized for fault tolerance in their hardware choices, relying on software to compensate for the lack of redundancy in some areas. It's a fascinating example of how software can drive down hardware costs.
I see. What about their approach to AI? That's a huge area of investment for many companies.
Meta's AI strategy is fully integrated. They're co-designing the entire stack, from PyTorch and Llama to the AI accelerators, networks, and even the data centers themselves. It's a holistic approach, unlike anything I've seen before.
That's incredible. What about their engineering culture? Does that play a role in their infrastructure design?
Absolutely. Their culture emphasizes technology openness, both internally and externally. They use a monorepo, which facilitates code reuse and collaboration. They also openly share many of their designs and technologies through open source initiatives. It's a collaborative approach that fosters innovation.
That's a refreshing take on things. So what are some of the future directions they're looking at?
They see AI as the dominant workload of the future, and they're already adapting their infrastructure to handle the unique demands of AI. They also anticipate a rise in domain-specific hardware and a significant expansion of edge data centers to support things like the metaverse and IoT. It's a constantly evolving landscape.
Fascinating. This has been a truly insightful look into Meta's infrastructure. Thanks for sharing this.
My pleasure. It's amazing to see how they've built such a massive and complex system with such a focus on efficiency and innovation. Thanks for listening to Tech Bytes and News. We'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating breakthrough in computer science, an undergraduate student's groundbreaking work on hash tables. It's a real game changer.
Wow, an undergraduate? That's incredible. What exactly did he achieve?
Exactly. Andrew Krapovin, while still an undergrad at Rutgers, essentially shattered a 40-year-old conjecture about hash table search speeds. He, along with his professors, demonstrated that searches can be significantly faster than previously thought possible.
Faster than what, exactly? I'm a bit fuzzy on the technical details.
Right, so the speed of hash table searches is often tied to how full the table is. Think of it like this. The fuller the table, the longer it takes to find an empty spot or a specific element. Previously, the best-case scenario, according to Andrew Yao's 1985 conjecture, was proportional to x, where x represents how close the table is to being completely full. A 99% full table meant you'd expect to check around 100 spots in the worst case.
Okay, I'm following. So Krapivin improved on that?
He completely upended it. His new hash table design, which uses a novel approach to pointer miniaturization, achieves a search time proportional to log x squared. A massive improvement. It's exponentially faster.
That's mind-blowing. So what was the reaction from the established computer science community?
Well, initially there was skepticism. His professor, Martin Faraj-Colton, was understandably cautious, but after William Kussmaul, another co-author, reviewed the work, he realized the implications. They had not just created a new hash table, they had disproven a long-held belief.
Amazing! And what about the practical implications? Will this change how we use hash tables?
That's a great question. While there aren't immediate, obvious applications, the theoretical implications are huge. It's a fundamental improvement to our understanding of a core data structure. As Alex Conway from Cornell Tech pointed out, better understanding of these structures could unlock future practical advancements. It's about laying the groundwork for future innovations.
I see. So it's a foundational discovery with potential for future applications. This is truly remarkable work.
Absolutely. And what's even more astonishing is that Krapivin's work also challenged another aspect of Yao's 1985 paper concerning average query times. Yao showed that for certain types of hash tables, the average query time couldn't be better than log x. Krapivin's team showed that this isn't true for all hash tables. They found a non-greedy hash table with a constant average query time, regardless of how full the table is. Completely unexpected.
That's just, wow. This really highlights the power of questioning established wisdom and the potential for unexpected breakthroughs, even in well-trodden fields.
Precisely. It's a testament to the power of curiosity and rigorous research, and a reminder that even in mature fields like computer science, there's still so much to discover. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of hash tables and this incredible undergraduate achievement. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the fascinating world of surnames and their surprisingly quirky origins. We'll be exploring how many common surnames are actually derived from nicknames, some of which are completely lost to time. Isn't that wild?
Absolutely. I've always been curious about the history behind names. So what's the main takeaway from this article? Is it just about tracing surnames back to their original nicknames?
Exactly. The core idea is that many surnames, like Johnson or Williamson, are patronymic, meaning they're derived from the father's name. But often, the father's name was a nickname, a shortened or altered version of a given name. And many of these original nicknames are now obsolete. Think about it. How many people do you know named Watt or Hobb?
None. That's a great point. So the article gives examples like Watt, a nickname for Walter, leading to surnames like Watson and Watkins, and Hobb, a nickname for Robert, resulting in Hobbs, Hobson, and Hobkins. It's like a linguistic detective story, uncovering these forgotten connections.
Precisely. The article even delves into the complexities. Sometimes, the diminutive suffix kin gets added, like in Wilkins, Little Will's son. Other times, the nickname's evolution is less clear, making it a real puzzle to trace. For instance, the origins of Gib, in Gibson, a nickname for Gilbert, were initially unclear to the author, highlighting the challenges in this etymological investigation.
I see. It's amazing how much linguistic evolution is hidden in plain sight within our surnames. The article also mentions that sometimes the original nickname is so obscure that it's completely forgotten, right? Making the connection even more challenging.
You got it. That's a key point. The author even solicits reader input, receiving numerous additions and corrections, demonstrating the collaborative nature of this etymological exploration. One reader pointed out that Robin isn't a shortened Robkin, as initially suggested, but actually a French diminutive of Robert. Talk about a twist.
That's fascinating. It shows how even experts can be surprised by these discoveries. The collaborative aspect is really cool too. It's like a crowdsourced etymology project. So the article isn't just a presentation of facts, but also a process of ongoing discovery and refinement.
Exactly. It highlights the dynamic and evolving nature of language and the ongoing effort to understand its history. The comments section, as mentioned, adds even more examples, like Dob for Robert, leading to Dobson, and Tib for Theobald, resulting in Tibbs and Tibbets. It's a testament to the richness and complexity of English surnames.
I think it's also a great example of how seemingly simple things, like our last names, can have such rich and complex histories. It makes you appreciate the layers of meaning and evolution embedded within everyday language. It's a reminder that even the most familiar things can hold unexpected surprises.
Absolutely. And that's why this article is so engaging. It's not just a dry recitation of facts, but a lively exploration of linguistic history, inviting readers to participate in the ongoing quest to unravel the mysteries of our names. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating world of surnames. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into SemiWiki's analysis of TSMC's 2 nanometers process, unveiled at IEDM 2024. It's a major advancement, folks.
Absolutely. I'm particularly interested in how it stacks up against the competition. What are the key takeaways from SemiWiki's assessment?
Well, TSMC boasted a 30% power improvement and a 15% performance boost over their 3 nanometers N3E node. They also claim it's the densest and most power-efficient 2 nanometers process out there. Early yield reports are promising too.
Impressive claims. But SemiWiki seems a bit skeptical, right? They mention a lack of concrete data in TSMC's presentation.
Exactly. The article points out that TSMC's IEDM presentation was more marketing than technical. There were no specific SRAM cell sizes, and all the performance graphs were relative, without actual units. A bit frustrating for those of us who crave hard numbers.
So how did SemiWiki actually assess the 2 nanometers process then? What methodology did they use?
They used a combination of the limited data from the paper, their own analysis, and previous node-to-node improvements from both TSMC and Samsung. They even incorporated data from Intel, where possible, to create a comprehensive comparison. They looked at power, performance, area, PPA, yield, and wafer pricing.
I see. And what were their findings regarding power efficiency? That 30% improvement sounds amazing.
Yeah, it is. But here's the kicker. They found a discrepancy. There was a power efficiency graph in an earlier version of TSMC's paper, showing a much higher improvement than the 30% claimed. It's interesting. The graph was removed from the final version, which raises some questions.
That's a significant discrepancy. What about performance and area? How did TSMC's 2 nanometers fare in those areas?
Based on their analysis, SemiWiki believes Intel's 18A process currently holds the performance crown, with TSMC in a close second and Samsung trailing. In terms of area, TSMC's 2 nanometers appears to be the densest, significantly ahead of both Intel and Samsung.
So TSMC leads in density and possibly power efficiency, but Intel takes the performance lead. Interesting. What about yield and wafer pricing? Those are crucial factors for adoption, right?
Absolutely. TSMC reported impressive yield numbers for a 256 megabit SRAM array, over 80% average and 90% peak. That's good news. However, the rumored $30,000 per wafer price is a major concern. SemiWiki believes that price is too high and could push customers towards Intel and Samsung.
That high price point could be a game changer. It seems like TSMC's 2 nanometers process is a mixed bag. Excellent density and yield, but potentially hampered by price and a slight performance deficit compared to Intel. What about backside power delivery?
That's another key area. Intel is leading the way with backside power delivery in their 18A process, expected to ramp in 2025. Samsung is following suit in 2026. TSMC, however, is lagging, not expected to implement it until 2026 at the earliest. This could be a significant advantage for Intel and Samsung, especially for high-performance computing applications.
So it seems the race to 2 nanometers is far from over. It's fascinating to see how these different strategies play out. Thanks for breaking down this complex analysis for us.
My pleasure. It's an exciting time in the semiconductor industry, and this is just one piece of the puzzle. Remember to check out the full article on SemiWiki for more detailed information. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into building a personal, private AI computer on a budget, a fascinating project detailed on ewintr.nl. The author cleverly tackles the issue of AI accessibility and control, right?
Absolutely. The article highlights a crucial point. The current landscape of AI is dominated by tech giants, right? Their business model often involves initially offering free or cheap services, hoping to capture market dominance before potentially monetizing through biased outputs or other means. Scary, huh?
Exactly. The author uses the example of DeepSeek's R1 and its refusal to discuss Tiananmen Square as a stark illustration of potential political bias in commercially driven AI. Chilling. But the solution? Building your own.
That's the exciting part. The article explores the possibility of running open-source LLMs like DeepSeek R1, Llama, and Gemma models locally. This allows for greater control and the potential to mitigate biases. But the hardware hurdle is significant, isn't it?
You bet. High-end GPUs or Apple computers are typically required, and the cost can easily reach thousands of euros. The author's clever approach? Second-hand.
Brilliant! Using pre-owned equipment significantly reduces the cost. The author details their build using two NVIDIA Tesla P40 GPUs, achieving 48 gigabytes of VRAM for around 1,700 euros. Impressive.
Indeed. But it wasn't without its challenges. The Teslas, designed for servers, lack built-in fans, requiring additional cooling solutions. The author had to overcome compatibility issues with their existing HPZ 440 workstation, including PSU compatibility and the need for a dummy GPU to satisfy the BIOS. A real engineering feat.
I see. The article meticulously documents the hardware choices, including the NZXTC 850 Gold PSU, a Gainward GT 1030 dummy GPU, and custom cooling solutions. The author even provides a script for monitoring GPU temperatures using Home Assistant. Amazing detail.
Precisely. The author also shares performance benchmarks, showing the tokens per second achieved with various models at different power levels. This provides valuable insights into the trade-off between performance and power consumption. Fascinating data.
Right. And the conclusion? The author expresses satisfaction with the project, highlighting the cost savings achieved by using pre-owned equipment and the satisfaction of having a locally run, controllable AI system. A testament to resourcefulness.
Absolutely. The article serves as a practical guide and inspiration for anyone looking to build their own private AI computer on a budget. It's a compelling example of how open-source models and clever resource management can democratize access to powerful AI technology. A truly inspiring project.
It certainly is. The author's detailed account, including the challenges faced and solutions implemented, makes it a valuable resource for anyone considering a similar endeavor. A must-read for DIY AI enthusiasts.
Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of the Flopotron 3.0, a truly remarkable musical instrument built from repurposed computer hardware. It's incredible.
Wow, 512 floppy disk drives? That's insane. I'm already intrigued. What's the core concept behind this thing?
Essentially, it uses the sounds of moving parts in old computer hardware, floppy disk drives, scanners, hard drives, to create music. Each device's motor or moving head generates a unique sound, and these are controlled precisely to play notes and rhythms. It's a symphony of clicks and whirs.
So it's like a giant, custom-built synthesizer? But instead of oscillators, it uses stepper motors and spinning disks? That's brilliant.
Exactly. The sounds are controlled via MIDI, just like a regular synthesizer. A custom gateway converts MIDI data into a protocol understood by the individual controllers for each instrument. It's a marvel of engineering.
I see. The article mentions a custom RS-485 network. Why not stick with MIDI directly? Wouldn't that be simpler?
That's a great question. Using RS-485 allows for a more scalable and robust system. MIDI's limited baud rate and daisy chain topology would be a bottleneck with this many devices. RS-485 provides a star topology, making expansion much easier. Plus, it allows for additional features like checksums for error detection.
Got it. So each instrument type has its own unique challenges. The floppy drives, for example, seem particularly complex.
Absolutely. Driving 512 floppy drives is no small feat. They're controlled in groups using custom daisy-chained adapter boards and clever programming tricks to manage the timing and signal generation. The creator even used the Nordic nRF52's PPI peripheral to offload some of the work from the CPU. Ingenious!
And what about the power consumption? With that many drives, it must be a beast.
Oh, it is! The Flopatron 3.0 draws up to 1.15 kilowatts at peak power. To handle this, the creator uses an array of 16 modular 5 volts 18A power supplies. Each module has its own overtemperature and short-circuit protection. Smart design.
The article mentions some quick and dirty solutions. What kind of compromises were made?
Well, for instance, the cabling for the floppy drives was a bit of a headache. The creator initially considered custom-made cables, but opted for a faster, cheaper solution using readily available rainbow cables, modifying them by hand. It's a testament to resourcefulness.
Amazing! So what's next for the Flopatron?
The creator plans to make videos showcasing the instrument's capabilities, fix some minor software bugs, and add features like end stops for the scanners. There are also plans for new instruments, such as a dot matrix printer. The possibilities are endless.
This is truly inspiring. It's a fantastic example of creative engineering and a love for repurposing technology. Thanks for sharing this.
My pleasure. And to our listeners, thank you for tuning in to Tech Bytes and News. We hope you enjoyed this deep dive into the incredible world of the Flopatron 3.0. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of static single assignment, SSA, a fundamental concept in compiler design. It's all about how to efficiently represent programs, making them easier to optimize. Ready to get technical?
Absolutely. I've always been intrigued by SSA, but the sheer number of papers on the topic can be overwhelming. What's the core idea behind SSA, and what are some of the key papers you've highlighted?
Exactly. The core idea is simple. Each variable is assigned only once. Sounds straightforward, but it has profound implications for optimization. Think of it like giving each value its own unique identifier, eliminating ambiguity. Now, about those papers. We have a rich history here, starting way back in the 1980s. Early work, like Zadek's papers on code motion and global value numbers, laid the groundwork. But the real breakthrough came with Citron's 1991 paper, which introduced a method for constructing SSA using dominance frontiers. It's a classic, but it involves some pretty heavy-duty graph algorithms.
So, Citron's approach is the gold standard? Not quite, right? I mean, it's influential, but not necessarily the most practical for all scenarios.
You're right to challenge that. While Citron's paper is seminal, it's not always the most efficient. Later papers offered simpler alternatives. Brandeis and Mossenbach's 1994 paper, for instance, showed you can generate SSA during parsing, bypassing the need for complex algorithms if you're dealing with structured languages without go-to statements. Much simpler, and often faster.
That's a huge simplification. So simpler approaches exist for specific cases. What about more recent developments, or two roaches? Are there any modern approaches that build upon these earlier ideas?
Absolutely. There's a whole range of approaches. Aycock and Horsepool's 2000 paper, for example, starts with Appel's crude algorithm and iteratively refines it, removing unnecessary phi nodes. Then there's Bebenita's 2009 work, which uses union-fine data structures for a very elegant solution. And even more recently, Lemaire's 2023 paper frames SSA construction as an abstract interpretation problem, a very advanced and powerful perspective.
Wow, this is a constantly evolving field. It's amazing how many different angles there are to tackle this problem. And what about the Sea of Nodes IR by Click and Polexny? That sounds particularly interesting.
Oh, the Sea of Nodes is a fascinating alternative. It essentially unschedules instructions, making code motion much easier. It's a different paradigm, but it shows the flexibility of the SSA concept. And of course, there's a whole world beyond the core algorithms. Extensions to SSA, analyses built on top of it, and the crucial task of converting out of SSA for register allocation. It's a deep rabbit hole.
It certainly is. This has been a fantastic overview. It's clear that SSA is far more than just a simple program representation. It's a rich area of research with many different approaches and ongoing developments. Thanks for shedding light on this complex topic.
My pleasure. And remember, listeners, this is just a glimpse into the world of SSA. There's a wealth of resources out there, including the comprehensive SSA book mentioned in the article. Keep exploring, keep learning, and happy compiling. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into the PDF Syntax project, a fascinating Python library for visualizing PDF file structures. It's really cool.
I'm eager to hear about this. What's the core idea behind PDF Syntax? Is it just another PDF viewer?
Not at all. It's not a viewer in the traditional sense. Think of it as a powerful tool for inspecting the internal workings of a PDF. It goes beyond just displaying the content. It lets you explore the underlying structure, the objects, the streams, everything.
So how does it achieve this visualization? Does it use some kind of graphical representation?
It uses HTML. It takes the raw PDF data, processes it, and generates a static HTML page. This page is not just a pretty printed version of the PDF data, but an interactive one, with hyperlinks connecting related elements. It's like a hyperlinked map of the PDF's internal structure. Even without JavaScript, it's surprisingly usable.
That's ingenious. So it's essentially a static HTML report of the PDF's internal structure? How does the user interact with it?
Exactly. The HTML includes features like a reverse index showing where objects are used, a page index for navigation, a minimap, and even pretty printed dictionary objects. It handles object streams, decompresses streams, and displays parts of them. It even color codes important elements for better readability. There's a live demo available, by the way.
A live demo? Where can we find that? And what about installation? Is it difficult?
You can find the demo at pdfsyntax.dev/simpletextstring.html. It's a simple example, but it showcases the capabilities beautifully. Installation is a breeze. You can install it via pip install pdf syntax. Then, you just redirect the standard output to an HTML file, python 3-m pdf syntax browse file, .pdf greater than inspection underscore file, HTML.
That's incredibly straightforward. What are some of the limitations? I mean, it's still under development, right?
You're right, it's still a work in progress. Currently, encrypted PDFs aren't supported, but the developer is actively adding features. The roadmap looks promising, and the documentation is quite good, I must say. It's well structured and easy to follow.
So to summarize, PDF Syntax is a powerful, easy-to-use tool for inspecting the internal structure of PDF files. It generates interactive HTML reports, making it easier to understand the complex relationships within a PDF. It's a great example of a well-designed, practical tool.
Precisely. It's a fantastic project, and I'm excited to see how it evolves. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of PDF analysis. Have a great day, everyone.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Draymar's Big Bag of KBD Tricks, a fascinating exploration of the Extend keyboard layer. It's all about maximizing efficiency and minimizing mouse use. Exciting, right?
Absolutely. I've heard whispers of this Extend thing, but I'm still a bit fuzzy on the details. What's the core concept?
At its heart, Extend brings navigation and editing commands to your home row. Think of it as supercharging your keyboard. Instead of reaching for arrow keys or function keys, you use modifier keys combined with home row keys to execute commands. It's all about positional efficiency.
So it's a layer, like a FN layer on some laptops, but way more powerful?
Exactly. But unlike a simple FN layer, Extend is designed for seamless integration and extensibility. It's not just arrows. It's multimedia controls, window management, text editing, even browsing shortcuts, all from the home row. It's incredibly customizable.
Whoa! How does the customization work? Is it difficult to set up?
The author uses EPKL, Enhanced Portable Keyboard Layout, for Windows and XKB for Linux. There are detailed instructions and even ASCII maps provided. It's not a trivial setup, but the payoff is huge. You can even create custom layers for specific applications or tasks.
That's impressive. But what about compatibility? Does it work across different operating systems and keyboard layouts?
Mostly. The core concepts are oxygen monosulfide agnostic, but the specific implementations differ. The mappings are mostly positional, so they adapt to different keyboard layouts like Colmac or Dvorak, with some adjustments for ergonomic modifications like curl or angle wide. Mac support is mentioned as less developed, though.
Okay, I'm sold on the concept. But what are some of the killer features that really make Extend shine?
Well, there are so many. The text editing capabilities are amazing. Selecting words, lines, paragraphs, even entire documents becomes incredibly fast. Window management is streamlined too. Switching between apps, resizing windows, all from the home row. And the browsing features. Oh my!
Tell me more about the browsing.
Extend integrates seamlessly with browser shortcuts. Back, forward, opening links in new tabs or windows. Even a quick find feature in Firefox, with plugins for other browsers, that lets you search for text or links without using the mouse. It's truly transformative.
This sounds almost too good to be true. Are there any downsides?
Well, the initial learning curve is steep. It takes time and practice to master all the combinations. And the setup process, as I mentioned, isn't exactly plug and play. Also, some features might require tweaking depending on your OS and browser.
I see. So it's a commitment, but a potentially rewarding one. It sounds like a game changer for power users.
Absolutely. It's not for everyone, but for those willing to invest the time, Extend offers a level of keyboard control and efficiency that's hard to match. It's a journey of discovery, constantly revealing new ways to optimize your workflow. It's truly empowering.
Thanks for the detailed overview. This has definitely piqued my interest. I'm ready to explore this further.
You're welcome. And remember, listeners, check out Draymar's website for all the details and resources. Until next time, this has been Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating story about how indigenous engineers are leveraging AI to preserve their cultures. It's a truly inspiring initiative, isn't it? Amazing!
Absolutely. The urgency is palpable. I mean, the statistic that an indigenous language dies every 2 weeks is shocking. It highlights the critical need for innovative solutions like this.
Exactly. Michael Running-Wolf, founder of Indigenous in AI, is leading the charge. His initiative, First Languages AI Reality, is building speech recognition models for over 200 endangered indigenous languages in North America. That's a monumental undertaking.
It is. But he faces a huge challenge, a severe shortage of indigenous computer scientists. He rightly points out that this isn't just about technical skills. It's about cultural understanding and respect for the data, which, in this case, is deeply personal and often linked to deceased speakers.
You're right. He emphasizes the ethical considerations, ensuring community involvement in data handling. It's not just about preserving the language. It's about preserving the cultural context and respecting the legacy of those who spoke it. It's a beautiful and crucial aspect of the project.
And the numbers are stark. Indigenous people represent a tiny fraction of the tech workforce, holding less than 0.005% of positions in the U.S. This lack of representation is a major hurdle to overcome.
Absolutely. That's why initiatives like Tech Natives, Indigigenius, and the Wihanable Sana Center for Indigenous AI are so vital. They're actively working to train the next generation of indigenous tech professionals. It's inspiring to see this grassroots effort.
Tech Natives, for example, provides mentorship and recruitment opportunities, empowering indigenous women in tech. Kyra Kaya, a student in the program, is developing an AI tool to preserve Hawaiian Pidgin English, a language often stigmatized. She's using AI to challenge those negative perceptions.
That's powerful. It shows how AI can be used not just for preservation, but also for reclaiming and celebrating marginalized languages and cultures. And Indigenius's Lakota AI Code Camp is another fantastic example, teaching native teens to design apps that document their culture.
It's a holistic approach, addressing the pipeline problem from multiple angles. They're not just teaching coding, they're fostering cultural pride and technological empowerment simultaneously. It's brilliant.
And it's not just about language. Madeline Gupta's work on creating a virtual reality experience to reconnect native youth with their ancestral lands is equally compelling. It uses technology to bridge the gap created by historical injustices.
I think that's a really important point. It shows the versatility of AI in cultural preservation. It's not limited to language. It can be applied to other aspects of cultural heritage, like land and traditions.
Precisely. And Suzanne Kite's work, using AI to translate Lakota dream language into geometric patterns used in traditional art, is another stunning example of this creative application. She's pushing the boundaries of what's possible.
It's all incredibly innovative and inspiring. It shows how technology can be a powerful tool for cultural revitalization, not just preservation. It's about reclaiming narratives and empowering communities.
Absolutely. While these projects are still in their early stages, the potential is immense. Running Wolf's hope is that, in a decade or two, these initiatives will be seen as artifacts of a time when such drastic measures were needed. A hopeful vision indeed.
A testament to the power of technology when used ethically and responsibly, guided by cultural understanding and a deep respect for heritage. It's a truly inspiring story.
Thank you for joining us on Tech Bytes and News. We hope you found this discussion as inspiring as we did. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating exploration of C++26 reflection and its application to implementing keyword arguments, a feature typically associated with scripting languages like Python. It's a really clever use of upcoming language features.
I'm eager to hear this. Keyword arguments in C++? That sounds incredibly challenging. What are the core hurdles the author tackles?
The main challenge is that C++ traditionally relies on positional arguments. The author explores several pre-reflection approaches, like designated initializers and helper objects. But these fall short. Designated initializers require extra syntax and don't handle optionality well. Helper objects, while functional, become cumbersome with many arguments.
So reflection is the key to unlocking this. How does it change the game?
Exactly. C++26 reflection allows the author to dynamically create types at compile time. Instead of predefining structures for every argument combination, reflection lets the code generate a named tuple based on the arguments passed. This tuple then becomes the input to the function.
That's brilliant. So it's like the compiler builds the perfect data structure on the fly? But how does it handle optional arguments?
Good question. The author uses techniques like URL, get underscore, or to provide default values if an optional argument is missing. It's all done with compile time checks, ensuring type safety and preventing runtime errors. It's elegant and efficient.
And what about the syntax? Does it look anything like Python's keyword arguments?
Not exactly. The author uses a macro called make_args to create the keyword argument tuple. It's not as clean as Python's syntax, but it's a significant improvement over previous methods. There's also a discussion of using user-defined literal operators to make it slightly more concise.
I see. The macro approach seems a bit less intuitive, though. Isn't there a risk of making the code less readable?
You're right, that's a valid concern. The trade-off is between readability and the power of having keyword arguments in C++. The author acknowledges the verbosity and suggests potential improvements, like leveraging lambda captures for a more concise syntax. But even with the macro, it's a huge step forward for C++.
Interesting. The article also mentions parsing the lambda capture list to get argument names. That sounds complex.
It is. The author implements a parser to extract argument names from the lambda's capture list, handling various capture styles, including references. It's a non-trivial task, but it's necessary to overcome the limitation of unnamed lambda captures. The author even discusses handling potential parsing errors.
Wow, this is deep. So the whole thing relies on several proposed C++26 features?
Yes, it heavily relies on reflection, expansion statements, or a similar helper. and function parameter reflection. The author clearly states that this is all experimental and depends on a specific Clang fork. But the potential is huge.
It certainly is. The article even touches on extending this to format strings, right?
Yes. The author cleverly adapts the keyword argument approach to work with STD, format, transforming the format string to use positional arguments instead of named ones. It's a remarkable demonstration of the flexibility of this technique.
This is a fascinating deep dive into the future of C++. Thanks for summarizing this.
My pleasure. It's a testament to the power of C++26's proposed features and the ingenuity of the author. Remember to check out the GitHub link for the full implementation. And that's all for today's Tech Bytes and News. Thanks for listening, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating paper, Scaling Up Test Time Compute with Latent Reasoning, a Recurrent Depth Approach. It's a game changer, really. This paper introduces a novel language model architecture that's all about scaling up computation during the testing phase, not training. Pretty cool, huh?
That sounds intriguing. So instead of scaling up by generating more tokens like most models, this one uses a recurrent block, right? Unrolling to arbitrary depth at test times? What does that even mean?
Exactly. Instead of generating more tokens, it iterates a recurrent block, essentially deepening the network at test time. Think of it like this. You have a basic reasoning block, and you can run it again and again, making the reasoning process deeper and more complex. It's like building a taller tower, block by block, instead of building a wider one.
I see. So it's a depth-first approach rather than a breadth-first one. But how does this avoid the need for specialized training data, as the paper claims? Most reasoning models need that, right?
That's the really clever part. It doesn't require specialized training data because it reasons implicitly in latent space. It's learning underlying representations, not explicit reasoning steps like chain-of-thought models. It can work with smaller context windows too, which is a huge advantage.
So it's learning the how of reasoning, not the what. Is that a fair assessment? And how does it compare to chain-of-thought methods in terms of the types of reasoning it can capture?
Yeah, pretty much. It captures reasoning types not easily expressed in words. Chain of thought needs those explicit steps, making it less flexible. This approach is more implicit, more powerful in a way. It's scaled to 3.5 billion parameters and 800 billion tokens, which is, well, impressive.
Wow, those are some serious numbers. And the paper claims performance improvements on reasoning benchmarks, sometimes dramatically, up to the equivalent of a 50 billion parameter model? That's a huge leap in efficiency, isn't it?
Absolutely. It's achieving performance gains far beyond what its parameter count suggests. That's the real breakthrough here. It's not just about brute force scaling. It's about smarter scaling. They even provide the model and code online, so you can check it out yourself.
This is incredibly exciting. It seems like this approach could significantly impact the field. Are there any limitations mentioned in the paper? Any potential downsides to this recurrent depth approach?
Well, it's still a proof of concept, so there's always room for improvement. And while it's efficient at test time, the training process itself might still be resource intensive, but the potential benefits are enormous. This could revolutionize how we approach large language model reasoning.
Definitely. This is a significant advancement. Thanks for breaking this down for us. It's clear this recurrent depth approach is a promising direction for scaling up language models.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating history of Digital Equipment Corporation, DEC, a company that profoundly impacted the computing landscape. We'll trace its journey from a basement startup to a major player and explore the key decisions that shaped its rise and fall.
Fantastic! I'm particularly interested in how DEC managed to challenge the established giants of the time, like IBM. What were their initial breakthroughs?
Absolutely. It all started with Ken Olsen, a man with an insatiable curiosity and a knack for innovation. He, along with a small team, built the Texas Zero, a fully transistorized computer, in the basement of MIT. This was revolutionary. significantly smaller and faster than existing behemoths like Whirlwind. The key? Interactive computing. Imagine the difference between waiting days for batch processing and getting immediate feedback.
That's a huge leap. So how did this lead to the creation of DEC?
Olson, along with Harlan Anderson and his brother Stan, saw the potential for small, affordable, interactive computers. They secured funding from AR&D, one of the first venture capital firms, and, incredibly, promised profitability within a year. They initially focused on selling circuit modules, essentially building blocks for computers, before tackling complete systems. Their headquarters? An old woolen mill in Maynard, Massachusetts.
An old woolen mill? That's quite a setting for a tech revolution. What was their first big hit?
The PDP-1. It was revolutionary for its time, relatively inexpensive, easy to use, and interactive. Olson himself said it was designed to be simple, fast, and affordable, allowing individuals to use computers in ways previously unimaginable. It was a game changer, paving the way for personal computing, even if the price point was still high by today's standards. Think about it. A computer you could actually use interactively, not just submit jobs and wait.
It sounds like they really understood the user experience, even back then. But how did they maintain this momentum? What followed the PDP-1?
They kept innovating. They developed a modular design, using their own circuit boards, which allowed for flexibility and scalability. They also listened to their customers, adapting their designs to meet specific needs. The PDP-8, a smaller and even more affordable machine, became a massive success, selling over 50,000 units. This was driven by their focus on simplicity and low cost, studying household appliances for design inspiration. Can you believe it? It's amazing, really.
That's incredible. So they were constantly iterating and improving their designs. What about their larger systems? Did they continue to innovate there as well?
Absolutely. They moved into larger systems with the PDP-10 and the PDP-6, which were significant for their time-sharing capabilities. These machines played a crucial role in the development of early networking technologies, and even hosted some of the earliest versions of Unix. The PDP-10 in particular was a powerhouse, powering early ARPANET development and even hosting the creation of Altair Basic.
Wow, that's a significant contribution to the history of computing. But eventually, DEC faced challenges. What led to their decline?
That's a complex question. While some point to their late entry into the personal computer market, I think the real issue was a combination of factors. The cancellation of the PRISM project, a promising RISC architecture, was a huge setback, leading to a loss of key talent. The company also grew too quickly, becoming unwieldy and struggling to adapt to the rapidly changing market. The rise of IBM PCs and the increasing popularity of Unix workstations further eroded their market share. It's a cautionary tale of a company that, despite its innovations, couldn't quite keep up with the pace of change.
So it wasn't just one thing, but a confluence of factors. It's a fascinating story, though. The legacy of DEC is undeniable.
Absolutely. DEC's impact on computing is immense. Their machines were instrumental in shaping the industry, and their innovative spirit continues to inspire. They were pioneers in interactive computing, modular design, and customer focus. Their story is a reminder that even the most successful companies can fall if they fail to adapt to the ever-evolving technological landscape. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the history of DEC. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a truly bizarre and brilliant feat of engineering, solving Sudoku puzzles using TMUX. It's not your typical Python script, folks.
Oh, this sounds wild. I've heard of TMUX, the terminal multiplexer, but a Sudoku solver? What's the core idea here?
The author cleverly uses TMUX features like hooks and variable expansion to create a program that iterates through possible solutions. It's not elegant, it's brute force at its finest. He even avoids arrays and strings, relying on TMUX options as variables.
No arrays or strings? That's intense. How does it represent the Sudoku grid then?
Each cell is a TMUX option, like at x2, y0 feet 4. Tedious to set up manually, so he wrote a script to convert a human-readable grid into these TMUX commands. The blank cell's coordinates are stored in another option, a string like 001, 03, 05, 06, 07, 080, 112, 17, 18, 10, 212, 3262, 0333, 5383, 042, 43, 444.
So how does it actually solve the puzzle? It's not using any sophisticated algorithms, right?
Exactly. It's pure brute force. It checks if the grid is solved using a massive variable expansion. Imagine concatenating all rows, columns, and 3x3 blocks into strings, and then checking if each contains all digits 1 to 9. This check is done with TreatMux's string matching capabilities.
That sounds incredibly inefficient. How does the control flow work? Does it use loops or something?
No loops, surprisingly. It uses TreatMux's if command with variable expansion for conditional logic and a recursive send keys trick. It's like a state machine jumping between two key bindings. One checks if solved, the other increments a blank cell and recursively calls itself.
A recursive send keys trick? That sounds like a recipe for disaster. How does it avoid infinite recursion?
Good question. It's carefully designed to avoid that. The recursion is managed by the key bindings and the send keys command, jumping between states. It's incredibly clever, but also incredibly fragile. One wrong keystroke, and you're in for a world of pain.
I see. So how fast is this monstrosity?
Not fast. For a Sudoku with 4 missing numbers, it took 41 seconds. With 5 missing, it took almost 7 minutes. The author estimates that for a typical easy Sudoku, it would take an astronomically long time. It's a testament to how inefficient this approach is, but also how much you can do with TMUX if you're determined enough.
Amazing. It's a fascinating example of pushing the boundaries of what's possible, even if it's not the most practical solution. Thanks for breaking this down for us.
Absolutely. It's a reminder that sometimes the most interesting projects aren't about efficiency, but about exploring the limits of a system. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating 524 error encountered on the website r.gina.ai. It's a timeout error, which means the server took too long to respond.
Right, a 524 error. That usually points to a problem on the server side, not the user's end, correct? So it's not my internet connection?
Exactly. The error page itself, beautifully designed I might add, clearly states that the origin web server timed out. It's not a Cloudflare issue. Cloudflare's status is showing as working. The problem lies with r.gina.ai itself.
I see. So what are the likely culprits? The error message mentions overloaded resources.
Yeah, it's a pretty standard explanation. The server might be overloaded by a background task, a database query that's taking forever, or even a poorly performing application. Think of it like this. Imagine a restaurant where the kitchen is swamped with orders. The waiters, Cloudflare, are ready, but the kitchen, r.gina.ai, can't keep up.
That's a great analogy. So the website's owners need to optimize their server resources. Is there any specific information on how to troubleshoot this?
Absolutely. The error page helpfully provides a link to Cloudflare's support documentation. It suggests working with their hosting provider or development team to identify and resolve the bottleneck. It could be anything from database tuning to code optimization, or even just upgrading their server hardware.
It also mentions a Cloudflare Ray ID. Is that relevant for troubleshooting?
Good catch. The Ray ID 9104B5D6DDBC3FF0 is a unique identifier for this specific request. It's useful for Cloudflare's support team to track down the issue if the website owner contacts them for help. It's like a case number.
Interesting. So basically, the user's experience is impacted because the server is struggling to handle the request. It's a classic case of resource exhaustion.
Precisely. And the error page is pretty user-friendly, even providing separate advice for website visitors. Try again later. And website owners. Optimize your server. Well-designed error pages are crucial for a good user experience.
I agree. It's a good example of how a technical problem can be communicated clearly and effectively, even to non-technical users. The visual representation of the browser, Cloudflare, and host statuses is also very helpful.
Absolutely. The color coding, green for working, red for error, makes it instantly clear where the problem lies. It's a simple but effective way to present complex information. So listeners, if you encounter a 524 error, remember it's usually a server-side issue, and patience, or contacting the website owner, is key.
And remember to check the error page for helpful troubleshooting tips. Often, the error message itself provides valuable clues.
Exactly. Thanks for joining us on Tech Bytes and News. We hope you found this discussion informative. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into relational quantum mechanics, RQM, a fascinating interpretation of quantum theory. It's a real game changer, you know?
I'm eager to hear this. What's the core idea behind RQM that sets it apart?
The big shift is that RQM focuses on the values of physical variables, not the wave function itself. Think of it like this. Instead of a mysterious wave function describing a system, we have concrete events, a particle being at a specific position at a specific time. These are relational events.
Relational? So, the value of a variable isn't inherent to the system?
Exactly. The value is relative to another system. Like velocity, you only have a velocity relative to something else. RQM extends this idea to all physical variables. A system's properties only have meaning within the context of its interactions.
That's a pretty radical departure from traditional views, isn't it? What about the observer? Does that play a special role?
No, not really. The observer is just another physical system. It's not a special, classical entity separate from the quantum world. Any system can be the observer in RQM. It's a more democratic approach.
I see. So, how does RQM handle the wave function then? Isn't that central to standard quantum mechanics?
Right. In RQM, the wave function isn't a property of a single system. It describes the relationship between two systems. It encodes information one system has about another, based on their past interactions. It's a relative state, not an absolute one.
Interesting. So no collapse of the wave function?
Well, the concept of collapse is different. The state, relative to one system, changes when it interacts with another, but it doesn't imply a universal, absolute collapse. The change is only relative to the interacting system.
And what about superposition? The famous Schrödinger's cat thought experiment?
Yes. In RQM, a cat in a superposition doesn't mean it's half alive, half dead. It means that its interactions with the environment will yield either a live or dead cat, with certain probabilities. The superposition is about the potential outcomes, not the cat's actual state.
So the superposition is a description of the possibilities, not a description of reality itself?
Precisely. And this neatly avoids the measurement problem. The act of measurement is just another interaction, and the outcome is relative to the measuring system.
That's a compelling argument. But how does RQM relate to other interpretations, like many worlds?
Both RQM and many worlds stem from Everett's work, but they differ significantly. Many worlds postulates a universal wave function with branching universes. RQM avoids this, focusing solely on relative states and interactions between systems.
So RQM is more parsimonious?
Yes, much more parsimonious. It doesn't require the vast ontological commitment of many worlds. It's a more minimalist approach, focusing on what's directly observable through interactions.
This is fascinating. But doesn't this relational view lead to some kind of solipsism? If everything is relative, how can we have shared knowledge?
That's a common concern. But RQM doesn't imply solipsism. The key is that interactions create correlations between systems. These correlations allow for shared knowledge and agreement on observations, even though the values themselves are relative.
So the correlations are the objective reality, not the individual values themselves?
Exactly. The correlations are what we can observe and agree upon. It's a shift in perspective, but a powerful one.
This has been a truly enlightening discussion. Thank you.
My pleasure. It's a complex topic, but hopefully we've shed some light on the core ideas of relational quantum mechanics. Thanks for listening to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the fascinating world of TinyX, a lightweight X server. It's a GitHub project, and it's really interesting.
Lightweight X server, you say? Intriguing. What makes it so special compared to, say, Xorg?
Well, the core idea is minimalism. TinyX aims for the smallest possible fully featured X server binary. They've stripped out a lot of features that, many users don't need. Think XKB, Shinorama, even GL support, all gone to keep the footprint tiny.
So it's all about efficiency and resource usage? Amazing!
Exactly. Perfect for embedded systems or low-resource machines. The project's README highlights this, emphasizing its suitability for situations where Xorg is simply too bulky. They even mention using it with TinyCore Linux, which makes perfect sense.
I see, but the README also mentions something about version 1.2.0 being the last working released version. Why not 1.3.0 or later?
Yes. Apparently 1.3.0 and later versions broke input functionality, keyboard and mouse support. They also introduced changes, like mandatory X input and XKB, which the TinyX developers disagree with. So they've essentially resurrected an older, stable version and are maintaining it.
That's a bold move. Interesting choice. So, what's the licensing situation? Is it all MIT?
Not quite. The original codebase might be MIT, but their modifications are under the GPLv3 license. They explicitly state that supporting closed devices isn't a goal.
Makes sense, given their open source ethos. Right? The GitHub page shows a good number of stars and forks, indicating a decent level of community interest.
Absolutely. Over 300 stars and 35 forks. That's a pretty healthy community for a niche project like this, and it's actively maintained, with recent commits as of November 2024, showing ongoing development and bug fixes.
So for developers needing a lightweight X server, this seems like a strong contender. It's a testament to the power of community-driven development and the value of focusing on core functionality.
Precisely. It's a great example of how a smaller, more focused project can fill a specific need better than a larger, more general-purpose one. And the fact that it's actively maintained, despite being a fork of an older version, is impressive. It's a project worth keeping an eye on.
Definitely. Thanks for shedding light on TinyX. It's been a fascinating discussion.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you enjoyed this deep dive into the world of TinyX. Have a great day, and we'll catch you on the next episode.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating blog post about injecting fun into software development, specifically during the creation of the Tapestry app. It's all about the unexpected joys and challenges of adding playful Easter eggs.
Sounds intriguing. I'm particularly interested in how they balance the serious work of software development with these fun additions. Did it impact the development process significantly?
That's a great question. The author argues that adding humor actually helped overcome daily frustrations. They posit that laughter combats stress, making the tough parts more manageable. It's a refreshing perspective, right?
Absolutely. So what's the first example of this fun they implemented?
The first example is a delightful fidget spinner animation. Initially, they just had a simple BETA badge, but then, on a Sunday afternoon, the author decided to add a springy animation to the badge that responded to taps. It was a secret project, even from his wife. The secrecy added to the excitement.
Wow, that's unexpected. And how did the team react to this surprise?
Oh, it was hilarious. They started getting user comments like, "I love the spinner," before anyone on the team even knew about it. The author had to reveal the secret on Slack. It also ended up being a useful tool for testing their error reporting. Tapping it too much triggered a zap the pram message. Pure genius.
That's brilliant. It's a great example of how a seemingly small, fun addition can have unexpected benefits, both in terms of user engagement and testing. What other fun elements did they add?
Next up is what they call the disco. One of their beta testers, Jolene, was a big fan of their app icons and requested alternate icons. Before releasing the alternate icons, the author added a placeholder message in the settings, teasing the upcoming feature. It was a clever way to build anticipation.
I see. A bit of playful teasing. But how did that lead to a disco?
That's where it gets really interesting. The placeholder message generated a bug report, which the author used as an excuse to learn a new Swift UI feature, Text Renderer, and to create a disco effect using all the app icons. He even personalized it by displaying the first names of all their Kickstarter backers in the About box, closing the bug report with a fun, personalized touch.
That's amazing. It's a perfect example of turning a potential problem into an opportunity for creative problem solving and user delight. So what's the overall takeaway from this blog post?
The main takeaway is that injecting fun into the development process can lead to unexpected benefits. It boosts morale, improves testing, and creates delightful user experiences. It's a reminder that software development doesn't have to be all serious work. A little bit of mischief can go a long way.
Absolutely. It's a refreshing perspective on software development. Thanks for sharing this insightful article. It's a great reminder to embrace creativity and fun in our work.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a truly remarkable story. Operation Beluga, a real-life Free Willy tale from February 22, 1985. It's a fascinating blend of natural history and Cold War tension, isn't it?
Absolutely. The juxtaposition is incredible. So what exactly happened during Operation Beluga? Was it a military operation or something else entirely?
Not a military operation in the traditional sense. It was a humanitarian rescue mission, but with a very unusual twist. A massive pod of beluga whales, thousands of them, became trapped in the Chukchi Sea by unexpectedly thick sea ice. Imagine miles and miles of ice, up to 12 feet thick, with these magnificent creatures struggling to breathe.
12 feet? That's terrifying. So how did they get trapped?
A perfect storm, really. A huge pod of belugas had gathered to feed on cod, completely unaware of the harsh weather conditions developing above. The cold and the winds pushed the sea ice into massive packs, effectively sealing them off from open water. It was a desperate situation.
I see. And what was the response? Did local hunters help?
Initially, yes. Subsistence hunters were initially thrilled at the abundance of food, but they quickly realized the long-term consequences of such a harvest. They understood the importance of preserving the species. So the call went out for help. Amazingly, the Soviet Union's icebreaker, the Moskva, was dispatched to the rescue.
The Moskva? That's a powerful icebreaker. But even with that, it must have been a monumental task, right? I mean, 15 miles of pack ice.
Exactly. The captain even considered turning back twice. The conditions were brutal. But they persevered, guided by snowmobiles and spotter planes. The whales, however, were terrified of the ship at first, taking days to acclimate.
That's incredible. How did they eventually manage to get the whales to move?
This is where it gets really interesting. Someone remembered that belugas communicate through sound and even respond to music. So get this. They started playing music over the Moskva's loudspeakers. Rock and roll, Russian folk tunes, even military marches. But the whales seemed most responsive to classical music. Shostakovich and Rachmaninoff, no kidding.
Wow, that's unexpected. So the music actually worked?
It did. Slowly, the whales began to follow the icebreaker, kilometer by kilometer, guided by the music and the ship's path through the ice. The New York Times and Izvestia both reported on the whales' apparent enjoyment of the rescue, describing them as happy as children. It's a truly heartwarming story.
It is. A remarkable tale of interspecies cooperation, set against the backdrop of the Cold War. It's a powerful reminder that even amidst global tensions, compassion and ingenuity can prevail. What a story.
Indeed. And it's a testament to the resilience of these incredible creatures. Operation Beluga is a story that will live in my heart forever. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this fascinating look at history. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of MUD servers and the ingenious copy-over technique. It's a bit of a throwback, but the underlying principles are still incredibly relevant. Let's get started.
I'm stoked. I've always been curious about how these older systems manage to stay online during updates. So this copy over, it's like a seamless server update, right? No downtime?
Precisely. It's a clever trick using fundamental Unix system calls to essentially replace the running server process without interrupting connections. Think of it as a surgical update.
Surgical sounds about right. So walk me through it. How does this magic happen?
Okay, so it starts with the admin initiating the copy over command. The server then creates a pipe, a communication channel between the old and new server processes. Then it uses fork to create a child process, a clone of itself.
A clone? Like an exact copy of the server's memory and everything?
Exactly. The child process then writes the current game state, all player data, locations, everything, into the pipe. Meanwhile, the parent process, using exec, replaces itself with the newly compiled server binary. Crucially, the file descriptors, including the network connections, remain open.
Whoa, that's elegant. So the new server inherits all the open connections?
Yes, the new server reads the game state from the pipe, essentially picking up where the old one left off. The parent process, now the new server, then cleans up the child process. The whole thing happens so fast, the players barely notice a blip.
But what if something goes wrong? What if the new server crashes during the process?
That's the biggest weakness. If the new server fails to start, you lose all that state. It's a risky operation. Modern approaches use more robust methods, like separate processes for network handling and game logic, communicating via Unix domain sockets, or even using systemd's file descriptor store for better resilience.
So this copyover method is a bit of a legacy technique, but the core idea, using system calls to achieve seamless updates, is still brilliant. It's a testament to the power of Unix primitives.
Absolutely. It's a beautiful example of how simple, well-understood tools can be combined to create something seemingly magical, and it highlights how much of this underlying magic is often hidden by modern abstraction layers. It makes you appreciate the elegance of the lower-level systems.
It's amazing how much you can do with just pipes, fork, and exec. It really shows the power of Unix. I'm definitely going to look into this further. Thanks for explaining it.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article about the surprising non-compliance of major mathematical libraries with the IEEE 754 floating point standard. It's a deep dive into the world of elementary functions, specifically the sine function, and the implications of this non-compliance. Exciting stuff!
Yeah, I saw this article too. I was shocked. The article claims that widely used libraries, even those claiming IEEE 754 compliance, aren't correctly rounding their elementary functions. Can you elaborate on what that means?
Absolutely. The IEEE 754 standard, introduced in 1985, aimed to standardize floating-point arithmetic across different platforms. The goal was portability and stability. The later revisions, particularly 2008 and 2019, recommend that elementary functions like sine, cosine, and logarithm should be correctly rounded, meaning less than 0.5 ULP, unit in the last place, error. This ensures consistent results across different implementations. But the author found that this isn't happening.
So these libraries are returning results with more than 0.5 ULP error? That's a significant deviation, right?
Precisely. The article uses the sine function as an example. It shows how different libraries, like Microsoft's CRT and Julia's implementation, produce different rounding errors, even though both claim to be within 1 ULP. The author presents graphs illustrating the error distribution, showing that the errors aren't uniformly distributed. This creates a kind of side channel, where the specific library used can be inferred from the output.
A side channel? That's unexpected. So it's not just about accuracy, it's about predictability and consistency across platforms. What's the impact of this non-compliance?
Exactly. The author mentions real-world consequences, like issues in deterministic planet generation for a multiplayer game, where different players saw different patterns due to these inconsistencies. He also explores the responses he got from various communities. Some dismissed the issue as insignificant, while others acknowledged the problem but were hesitant to fix it due to performance concerns. Some even suggested that the burden of handling these inaccuracies should fall on the user.
That's a pretty dismissive attitude, especially given the standard's explicit recommendations. What was the author's solution?
The author proposes a clever solution, implementing 32-bit sign functions using 64-bit calculations and then correctly rounding the result. He demonstrates that this approach achieves correct rounding with minimal performance overhead on modern hardware. He tested this across different languages and found it to be effective for most elementary functions, except for the logarithm, which required a slightly more sophisticated approach.
That's ingenious. So, essentially, a simple workaround to achieve compliance without sacrificing performance significantly. What's the overall takeaway here?
The main takeaway is that widely used mathematical libraries aren't adhering to a crucial aspect of the IEEE 754 standard, leading to inconsistencies and potential problems in sensitive applications. The author's work demonstrates that achieving correct rounding is feasible without significant performance penalties, highlighting the importance of adhering to standards for predictable and reliable results. It's a call for better adherence to the standard and a reminder that seemingly small inaccuracies can have significant consequences.
Absolutely. It's a compelling argument for prioritizing correctness and consistency over potentially marginal performance gains. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us again tomorrow for another deep dive into the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into real-time feature development patterns. Exciting stuff!
Absolutely. Real-time features are a must-have for modern apps. So what are the key patterns discussed in this article?
The article outlines several key patterns. First up is poke/pull. It's simple. The server pokes clients when an update happens, and clients pull the new state. Think of it like a waiter notifying you your food is ready. You then go get it.
I see. So what's the downside? The obvious scalability issue, right?
Exactly. Fan-out is a major problem. One update triggers multiple pull requests, potentially overwhelming the server, but caching and spreading out the pokes can help mitigate that.
Right, caching makes sense. Okay, what's next?
Next is push state. Here, the server proactively pushes the entire updated state to clients. It's more efficient than poke/pull, avoiding the multiple pull requests.
That sounds great, but doesn't pushing the entire state become inefficient with large datasets?
You're absolutely right. It's not scalable for large states. A tiny change means sending the whole thing again. That's where push-ops comes in.
Ah, push-ops. So instead of the whole state, you just send the operation that caused the change?
Precisely. You send only the necessary changes, making it much more efficient. For example, instead of sending the entire to-do list, you just send an update saying, "To-do item 2 is now complete." Much smaller, much faster.
Makes sense. And what about event sourcing?
Event sourcing focuses on sending the event itself, not the operation or the state. Instead of update to-do item 2 to complete, you send to-do item 2 completed. The client then handles the update based on the event. It's more purist, but requires more client-side logic.
Interesting. So it's a trade-off between server-side and client-side complexity.
Exactly. And finally, the article discusses transports. WebSockets, server-sent events, SSE, and others are all options, each with its own pros and cons. But the key challenge is scaling across multiple servers.
Right, horizontal scaling introduces complexities. How does the article suggest handling that?
Pub/subsystems. They handle the fan-out across multiple servers, making it much easier to manage updates in a distributed environment. It's a crucial consideration for real-time applications at scale.
So to summarize, we've covered poke/pull, push state, push-ops, event sourcing, and the transport challenges. A great overview of patterns for building robust real-time features.
Absolutely. Choosing the right pattern depends on your specific needs and scale. Remember to consider factors like data size, client-side complexity, and the need for scalability. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating legal debate surrounding the LLaMA large language model. It's a real nail-biter.
LLMA, you say? Sounds intriguing. What's the core issue here?
A bunch of authors are suing Meta and others, claiming copyright infringement. They argue that llama was trained on copyrighted material obtained without permission. The audacity!
So Meta just blatantly used copyrighted books? That seems reckless, to say the least.
Exactly. Their llama paper mentions using the Gutenberg project, which is public domain, so that's fine. But they also used Books 3 from the Pile dataset, and that's where things get messy.
Books 3, what's the story there?
Books 3 is essentially a massive dump of books from a private tracker called Bibliothek. Sean Presser, the one who shared it, described it as all of Bibliothek, a 37 gigabytes file.
Wow, and Bibliothek, what kind of books are we talking about?
Well, it was advertised as free indie books. But a closer look reveals many commercially published books, not just free ones. There's even a file listing that seems to include the books of the authors suing Meta.
So Meta essentially trained their AI on a massive pile of potentially pirated material? That's a huge problem.
It really is. It's like they openly admitted to training LLMA on IP obtained without consent. The blog post even points out that if a regular person did this, they'd be facing serious legal action.
I see. But isn't there a fair use argument to be made? I mean, summarizing a book isn't necessarily the same as reproducing it.
That's a valid point, and it's definitely part of the ongoing debate. But the core issue here isn't about fair use. It's about the illegal acquisition of the training data. It's a fundamental breach of copyright.
Right. It's like building a house using stolen lumber. The final product might be beautiful, but the process is completely unethical and illegal. This could set a dangerous precedent.
Absolutely. This case could significantly impact the future of AI development. It highlights the urgent need for ethical sourcing of training data. We need to ensure AI progress doesn't come at the expense of creators' rights.
It's a complex issue, but the core principle is clear. Respecting intellectual property is paramount. We can't just build amazing technology by ignoring the law and ethical considerations.
Precisely. And this case is a stark reminder of that. It's a fascinating legal battle, and we'll be sure to keep you updated on its progress. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Anthropic's groundbreaking economic index, a fascinating look at how II is reshaping the job market. It's revolutionary stuff.
Absolutely. I've been following this closely. The sheer scale of the data, millions of anonymized Claude.ai conversations, is mind-blowing. What are the key takeaways, from this initial report?
Well, the biggest surprise, perhaps, is the concentration of AI usage. Software development and technical writing are dominating the field. About 36% of occupations see AI in at least a quarter of their tasks, but only around 4% use it for the vast majority of their tasks. It's not a complete takeover, but a significant integration.
Interesting. So it's more augmentation than full-blown automation, right? The report highlights that, doesn't it?
Exactly. About 57% of AI usage is augmentative AI working alongside humans. Think collaborative writing, code debugging, that sort of thing. Automation, where AI replaces human tasks entirely, accounts for the remaining 43%. It's a nuanced picture, not a simple automation narrative.
And what about salary? I'm curious about the correlation between AI use and income levels.
That's a really insightful point. The data shows that AI use is most prevalent in mid to high wage occupations, like programmers and data scientists. Both low and high paying jobs show surprisingly low AI adoption. This suggests limitations in current AI capabilities and practical barriers to implementation.
So it's not just a matter of replacing low-skill jobs, but something more complex? That's a significant finding, I think. It challenges some common assumptions.
Absolutely. The report uses the ONET database to categorize tasks and occupations, providing a granular level of detail. They even compared AI usage across different job categories, showing a huge disparity between, say, computer and mathematical jobs, 37.2% AI usage, and transportation, only 0.3%.
Wow. That's a huge difference. And they've open sourced the dataset, which is fantastic for further research. This is a really important contribution to the field.
Yes, the open sourcing is key. It allows other researchers to build upon their findings, validate their methodology, and expand the analysis. They're also inviting feedback and suggestions for future research directions. It's a truly collaborative effort.
One thing that struck me was the caveat section. They acknowledge limitations, like not knowing for sure if Claude usage was work-related or not. That's crucial for maintaining scientific rigor, isn't it?
Absolutely. Transparency and acknowledging limitations are essential. They also point out that their data comes solely from Claude.ai's free and pro plans, not enterprise users, which could skew the results. But overall, it's a robust study with a novel methodology.
It's a really exciting development. This kind of longitudinal study, tracking AI's impact over time, is crucial for understanding its long-term effects on the economy and the labor market. It's not just about today's snapshot, but the future trajectory.
Precisely. The Anthropic Economic Index is not just a report. It's a commitment to ongoing research and data sharing. It's a powerful tool for understanding and shaping the future of work in the age of AI. And that's all the time we have for today. Thanks for joining us on Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating question posed to MIT's Ask an Engineer. Why haven't commercial airliners gotten faster since the 1960s? It's a great question, right?
Absolutely. I mean, everything else seems to be speeding up, so why not airplanes? I'm expecting some mind-blowing technological limitations, maybe some insurmountable physics problem.
Well, it's not quite that dramatic, but it's definitely interesting. The main reason boils down to fuel efficiency. Professor Mark Drila from MIT's Aeronautics and Astronautics Department points out that higher speeds mean significantly more fuel consumption per passenger mile.
Oh, I see. So it's not a matter of can we go faster, but should we, considering the cost?
Exactly. Think about those massive engines on modern jets, those high bypass turbofans. They're huge, right? They move a lot of air at lower speeds, maximizing efficiency. Older engines, like those on the Boeing 707, were smaller and moved less air at higher speeds, but they were far less fuel efficient.
So the trade-off is speed versus fuel efficiency, and fuel efficiency wins in the long run for commercial flights?
Precisely. And there's another factor: wing design. Slower planes can have less wing sweep, making them smaller, lighter, and cheaper to build. The 707's wing sweep was 35 degrees, while the 777's is only 31.6 degrees.
That's a pretty significant difference. So what about the Concorde? That thing was supersonic.
Ah, yes, the Concorde. A fascinating exception. But it operated in a very niche market and faced significant limitations. The sonic boom it generated was a major problem, leading to flight bans over land in many countries.
Right, the noise pollution. That makes sense. So is there any hope for faster commercial flights in the future?
There's some hope on the horizon, but it's mostly focused on supersonic business jets. Smaller size and innovative boom-shaping designs might mitigate the noise issue, and for private jets, the higher fuel consumption per passenger mile is less of a concern.
Interesting. So it's a matter of economics and noise pollution, not some fundamental technological barrier. I guess we'll just have to enjoy the current speeds, and maybe bring a good book for those long flights.
Yeah, exactly. For now, it seems the high bypass engine reigns supreme. But who knows what the future holds? Maybe some breakthroughs in materials science or propulsion systems will change things. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of aviation engineering. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into NOCC, a distributed C++ compiler developed by VK.com to drastically speed up their massive C++ compilation processes. It's a game changer, folks.
A distributed C++ compiler? That sounds intense. So how does it actually improve compilation times? Is it just throwing more processing power at the problem?
It's more sophisticated than that. While it does leverage multiple remote machines for parallel compilation, its real magic lies in its intelligent caching mechanisms. Think of it like this. The first time a .cpp file is compiled, it's sent to a remote server, compiled, and the resulting .o file is returned. But subsequent compilations of the same file, even on different machines or after a clean build, utilize the cached .o file, bypassing the entire compilation process. It's incredibly efficient.
So it's not just distributing the workload, it's also remembering what it's already done. That's clever. But how does it handle dependencies? What if a header file changes?
Excellent question. NOCC recursively tracks all #include directives, identifying all dependencies. If a header file changes, its hash is updated, triggering a recompilation only for files that depend on it. It's incredibly granular in its dependency management. Plus, it even handles system headers intelligently, uploading them only if they're missing or different on the remote machines.
Wow, that's impressive. So it's essentially a distributed compiler and a sophisticated caching system all rolled into one. What about integration with existing build systems like CMake and Ninja?
Seamless. For CMake, you just need to set the CMAKECXX compiler _ launcher variable to point to NOCC. Ninja works too, but there's a minor quirk with the daemon shutdown that requires a slightly different approach. The documentation covers this well, though.
I see. And what about the performance gains? The GitHub page mentions improvements ranging from 2x to 9x over their previous solution, DistTC. That's a huge leap.
Absolutely. They achieved a 5x speedup just by patching DistTC to support precompiled headers. But NOCC, with its more advanced architecture and caching, provides an even more significant boost. It's a testament to the power of smart design and efficient caching.
This is truly remarkable. It seems like NOCC addresses many of the pain points associated with compiling large C++ projects, especially in CI/CD environments. The remote caching alone is a huge win.
Precisely. And the fact that it's designed to be lightweight and easily integrated into existing workflows makes it even more appealing. It's not just a faster compiler, it's a smarter one. The whole architecture is really well thought out.
One thing I'm curious about is the choice of Go for the NOCC daemon and C++ for the client-side NOCC. Was there a specific reason for this?
That's a great point. I think the choice reflects a balance between performance and ease of development. Go's concurrency features make it well suited for the daemon's task of managing multiple connections and handling the caching logic. Meanwhile, C++'s performance makes it a good fit for the client-side wrapper, which needs to be lightweight and efficient. It's a smart combination.
It certainly seems that way. This has been a fascinating discussion. Thanks for shedding light on this impressive project.
My pleasure. And to our listeners, thank you for tuning in to Tech Bytes and News. We hope you found this discussion as insightful as we did. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into BTRF's Allocator Hints, a powerful feature for optimizing mixed device storage setups. It's all about getting the best of both worlds, speed and capacity.
Right, I've been hearing whispers about this. So the core idea is to prioritize faster storage for metadata, right? That's where the performance gains come from, because metadata operations are typically small and random.
Exactly. Think of it like this. Your metadata is the index of a massive library. You want that index to be lightning fast, so you put it on an SSD or NVMe. The actual books, your data, can be on slower, higher capacity HDDs.
Makes sense. But how does it actually work? Is it some kind of magic?
No magic, just clever patching. A series of patches, actually, refined over time by contributors like Goffredo Baroncelli and Kakra on GitHub. These patches allow you to configure the BTRF's chunk allocator to prioritize specific devices for metadata or data. You essentially tell the system, hey, use this SSD for metadata and this HDD for data.
So I need a patched kernel then. And how do I apply this patch? Is it difficult?
You do need a patched kernel. It's not overly difficult, but it does involve compiling your own kernel. The instructions are in the article, but it's pretty standard stuff. Download the source. Download the patch from Kakra's GitHub. Apply the patch using patch, P1, rebuild, and install. Each distribution has its own nuances though, so check your distro's documentation.
Okay, got it. And once I have the patched kernel, how do I actually configure the allocator hints?
You use the SYSFS interface. Each device in your BTRF's file system has a unique ID. You write a number, 0 to 5, to a specific SYSFS file for each device to indicate your preference. 0 means prefer data, 1 means prefer metadata, 2 and 3 are exclusive allocations, not recommended. 4 and 5 are for avoiding or preventing allocation, useful for devices you're removing.
Ah, I see. So 0 for HDDs, 1 for SSDs, generally speaking. But what about balancing? Does it automatically rearrange everything?
No, it doesn't automatically move existing data. You need to run BTRFS balance start. Usage equals 100 after changing the hints to redistribute chunks according to your new preferences. It's important to monitor the process using BTRFS file system usage -T to track progress and ensure everything is going as planned.
Interesting. One thing I noticed, the article mentions that free space calculations might not be entirely accurate after applying the patch. That's a bit concerning, isn't it?
Yes, that's a valid concern. That's one of the reasons why these patches aren't yet in the mainline kernel. The article strongly advises against relying on DF and instead using BTRFS device usage for accurate space monitoring. It's crucial to keep a close eye on your storage usage, especially if you're using the exclusive allocation types, 2 and 3.
So basically, it's a powerful tool, but it requires careful planning and monitoring. It's not a set it and forget it kind of thing.
Precisely. It's a powerful tool for optimizing performance and storage in BTRFs, especially in mixed device setups. But it demands attention. Think of it as fine-tuning your engine. You can get amazing performance, but you need to understand what you're doing and monitor the results carefully. And always back up your data.
Excellent advice. Thanks for breaking this down for us. This is definitely something I'll be experimenting with, but cautiously.
My pleasure. And remember, folks, always consult the official documentation and community resources for the most up-to-date information. That's all for Tech Bytes and News today. Have a great day, and happy computing.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discussion about trailing commas in SQL. It's a seemingly simple feature, but the implications are surprisingly complex, wouldn't you say?
Absolutely. The article highlights the seemingly simple request to allow trailing commas in SQL queries and table definitions, like in select A, B, C, or create table tab 1, A int, B int, C int. But the devil's in the details, right?
Precisely. The author points out that SQL has a ton of comma-separated lists, array constructors, row constructors, function calls, even command definitions. Implementing trailing commas consistently across all these is a monumental task.
He outlines 3 approaches: supporting only the most popular cases, supporting most cases except those causing conflicts, or rigorously supporting them everywhere. Each has its own set of problems. The first is arbitrary and leads to inconsistency. The second is vague. What constitutes too complicated? The third is, well, a massive undertaking.
Exactly. And the challenges extend beyond just PostgreSQL. Getting this into the SQL standard adds another layer of complexity. Imagine the nightmare of managing different conformance rules and feature codes across various implementations. If we go with a piecemeal approach, remember the C language's inconsistent trailing comma support across versions? A total mess.
Yeah, I remember that being a pain. The author also mentions DuckDB's attempt at trailing comma support. While it covers some common cases, it's not consistent, highlighting the difficulty of a comprehensive solution.
Right. It seems like a seemingly simple syntactic sugar addition, but the sheer number of places where commas appear in SQL makes it a huge undertaking. It's not just about adding a feature, it's about maintaining consistency and avoiding fragmentation across different SQL implementations.
So what's the way forward? The article doesn't offer a clear solution, does it? It seems like a trade-off between practicality and consistency.
You're right. It's a tough nut to crack. Maybe a phased approach, starting with the most common use cases and carefully evaluating the feasibility of expanding support over time. But even that requires careful planning and a clear definition of what constitutes a common use case.
It's a fascinating problem, highlighting the complexities hidden beneath the surface of seemingly simple features. Thanks for bringing this to our attention.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article from nuance.dev about giving AI coding assistants system-wide context. It's all about bridging the gap between code and the real-world operational data that makes software tick, you know?
Exactly. I've been following this space closely. The article highlights a major challenge. Developers constantly juggle multiple tools, AWS consoles, Kubernetes, Datadog, each demanding its own expertise. This context switching is a huge productivity drain, right?
Totally. The article points out that while AI coding assistants are getting amazing at code generation, they often miss the crucial system-wide context. This doesn't always lead to hallucinations, but it does mean developers spend extra time explaining the bigger picture to the AI.
So they conducted some experiments, right? What kind of data did they feed the AI?
Yeah, they used call graphs, memory profiler outputs, exception reports, and telemetry data. Think of it as giving the AI a holistic view of the system's health and behavior.
Interesting. And what were the results? Did feeding the AI all this extra information significantly improve its performance?
Well, it was a mixed bag. In one experiment using call graphs, the AI went from vague requests to pinpoint accuracy. But a huge call graph overwhelmed the AI's context window. It's a classic case of too much information being worse than none.
I see. So the representation of the data is crucial. It's not just about giving the AI more data, but giving it the right data in the right format.
Precisely. Their experiment with Datadog dashboards showed that directly feeding screenshots wasn't ideal. The AI struggled with visual data, missing key correlations. They had to deal with rendering issues, scrolling, and stitching multiple screenshots together. It was a real technical challenge.
That makes sense. Visual data is inherently complex. But what about the structured data experiments, memory profiling, and exception reports?
Those were more successful. With structured memory profiling data, the AI accurately identified memory bottlenecks. It could track memory usage patterns throughout the program's execution. Similarly, when given structured exception reports along with the source code, the AI went beyond simple error reporting and identified the root cause of a complex database timeout issue.
So structured data is key. It seems like the key takeaway is that AI assistants can be incredibly powerful when given the right context, but the way that context is presented is critical. It's not just about throwing data at it.
Exactly. The article concludes by discussing their nuanced graph, a knowledge graph that aims to integrate all this operational data to give AI assistants a truly holistic understanding of the system. They're starting with Python, but their vision is much broader.
It's an ambitious goal, but it sounds incredibly promising. This approach could revolutionize debugging and software development in general. Imagine an AI that not only understands your code, but also the entire system it operates within.
Absolutely. It's a game changer. And that's it for today's Tech Bytes and News. Thanks for joining us, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of gluons, specifically exploring how ultra-peripheral collisions at the LHC are helping us understand their dynamics. It's all about that missing 99% of the visible universe's mass.
Right. I'm buzzing to hear this. So the big question is, where does the mass of protons and neutrons come from? It's not the quarks, right?
Exactly. Quarks only contribute a tiny fraction, less than 1%. The remaining 99%? That's the magic of gluons and their self-interactions, binding quarks within hadrons. It's mind-blowing.
Mind-blowing indeed. But how do we study something so elusive?
That's where ultra-peripheral collisions, UPCs, at the LHC come in. They're like a clean laboratory. These collisions happen at large impact parameters outside the strong nuclear force's reach, keeping the nuclei intact. The result? Fewer particles to analyze, making it easier to spot the gluon's signature.
I see. So instead of smashing protons directly, we're using photons as probes? Clever.
Precisely. High-energy photons, generated by ultra-relativistic particles, act as point-like probes, interacting with the gluons. For heavy ions like lead, the photon flux is amplified, allowing us to study photon-proton and photon-nucleus interactions at incredible energies.
And what are we looking for specifically? Gluon saturation?
Yes. Gluon saturation is a dynamic equilibrium between gluon splitting and recombination, predicted by QCD. It's expected to halt the rapid growth in gluon density observed at HERA. We're looking for experimental evidence of this plateauing effect.
So the HERA experiments showed a power law increase in gluon density. The LHC experiments are trying to see if that trend continues or plateaus, right?
Exactly. ALICE and LHCb are pushing to higher energies and lower Bjorken X values than HERA ever could. They're looking for deviations from that power law, which would be a strong indication of gluon saturation. But so far, the power law continues for now.
Interesting. But there are other things besides gluon saturation, right? Like gluonic hotspots?
Absolutely. Gluconic hotspots are like localized regions of high gluon density within the proton or nucleus. These hotspots become more numerous and overlap as we approach gluon saturation. The LHC is probing these with unprecedented precision.
And then there's nuclear shadowing gluons, hiding in the shadows, so to speak.
Yeah, it's a fascinating effect. The European muon collaboration first observed it. Nuclei seem to have fewer gluons than expected. This is because the interaction of a probe with one gluon reduces the probability of it interacting with others. It's like they're hiding in each other's shadows.
So we have gluon saturation, gluonic hotspots, and nuclear shadowing, all intertwined and influencing each other. It's a complex picture.
It is. And the relationship between these phenomena is still not fully understood. Separating their effects is a major challenge. But the LHC, with its high energies and various colliding systems, is providing invaluable data. And the upcoming Electron-Ion Collider, EIC, promises to revolutionize our understanding.
The EIC sounds amazing. A multidimensional map of gluonic behavior. That's what we need.
Absolutely. But even before the EIC, the LHC's Run 3 and Run 4 will provide a tenfold increase in PBPB statistics, allowing for significant advancements in low Bjorken-X physics. Upgrades to detectors like ALICE's new high-granularity forward calorimeter will further enhance our capabilities. It's an exciting time for particle physics.
It really is. Thanks for breaking down this complex topic so clearly. This has been a fantastic overview of the cutting-edge research happening at CERN.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you enjoyed this deep dive into the world of gluons and the quest to understand the 99% of the universe's mass we've been missing. Until next time, goodbye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.